Hello, good morning, good evening, good afternoon, everyone. My name is Michaël Bikard, and I'm the director of digital at INSEAD. While we're waiting for Michaël Bikard to connect, please allow me to introduce the webinar today. So tonight, we will deep dive into DeepTech. So DeepTech, this webinar is part of a Tech Talk series that are dedicated to exploring new digital technology and the application, as well as impact on management, business, and society. So the Tech Talks are both technical and business talks presented by leading technologists, thought leaders, industry practitioners, innovators, entrepreneurs, and academics. Yes, so these tech talks span on a wide spectrum of topics on both emerging and existing technology and provide technology-specific insight as well as management, business, and societal perspective. So if you'd like to know more about digital at INSEAD, you can go on our website, digital.insead.edu. So as I mentioned earlier, today we're going to deep dive into DeepTech with Robyn Brazzil, who is the director of the innovation platform FedTech, Sophie Cahen, founder and CEO of Ganymed Robotics, and Brittany Corsi, founder of EarthXYZ. So the poll question is, please tick what best describes you. So are you an existing or aspiring founder in DeepTech? Do you work or look to work in DeepTech? Are you an existing or aspiring investor in DeepTech? Are you curious to learn more about DeepTech? Or maybe you are in the wrong webinar. So far, nobody is in the wrong webinar. All right, so I think most of you, we have 64% who are curious to learn more about DeepTech, and this is exactly what we're planning to discuss today. So allow me to ask the Robyn and Sophie and Brittany to put the video on and introduce themselves while we're still waiting for Michaël.
I'm here.
All right, please, Michaël, please put your video on, and then so we can carry on with.
You see my video, right?
Yeah, we can see you.
Yes. Okay. Good. I'd like to share my screen. I'm Michaël Bikard. I'm an associate professor here at INSEAD, and it is really a great pleasure to be here today to talk about DeepTech, something I've been doing research on for a long time. I want to start this with a few stories. The first story is a story of a professor from the University of Chicago called Jean Goldwasser. Jean Goldwasser spent his entire career studying one molecule and trying to find it. And he finally discovered that molecule in 1977. That molecule is EPO, erythropoietin, the human hormone that regulates the production of red blood cells. When he finally, after decades of work, discovered EPO, he knew that he had something that was going to change the world. It was going to make the life of millions of people suffering from anemia better, save their lives. It was going to create a very extremely valuable drug. And so he went to companies to, so he first went to the university transfer office to tell them, hey, I have a very valuable intellectual property here. We should do something with it. And they were not interested. He didn't lose hope. He went to Park Davis in Michigan, telling them that he had something incredible and that they should be working on it. And they turned him down over and over again. And he still didn't lose hope. He went to the largest pharmaceutical company in the Chicago area, Abbott, offering them on a silver platter the scientific foundation for $1 billion drug. And they turned him down over and over again. And so his discovery, the purified assay of erythropoietin, remained unused in his lab for 5 years until some random guy who had been in his lab took a postdoc at UCLA and then ended up working at a startup. The name of that startup was Amgen. At the point of this story, sometimes extremely valuable ideas remained unused in university labs. The second story I want to tell you about is a lot more recent, but it has echo of this one. It's the story of Kathleen Carrico. Many of you may have heard that story before. She's been in the news a lot, and she deserves to be. She grew up in a poor family in Hungary during the Soviet era. Her dad was a butcher, her mom was a bookkeeper. They didn't have a fridge, they didn't have running water at home. But she loved science, and she decided to go into science. And she managed to do very good studies in Hungary, got a postdoc at a famous Hungarian university, but then the lab ran out of money. And by 1986, she went out of a job. So at that point, she and her husband decided to leave Hungary to go to America, try their luck in America. They sold their car in the black market, took the 900 British pound that they got from this, put them in the teddy bear of the 2-year-old daughter to escape the Soviet Union, the Iron Curtain, and flee to America. At that point, you'd think that things got better, but they didn't. She really struggled. First, she got a job at Temple University and then at University of Pennsylvania, but she really struggled. She couldn't get published. She couldn't get grants. She had one big idea that mRNA could be used to produce vaccines, but no one believed in it. And UPenn at some point wanted to fire her, but she kept going, she kept going. She was demoted, she kept her job, she kept going. And then by 1997, I believe, she ended up meeting a PI, a professor at the University of Pennsylvania called Drew Weissman. And Drew Weissman decided to give her a shot, and they worked together, and they ended up in 2005 and 2006 publishing the key papers of how you could use mRNA to produce an entirely new generation of vaccines. She tried to commercialize it, were not successful at it. However, other people were. Thank to her and thank to them, we now have the Moderna and Pfizer BioNTech vaccines. Many of us will have it at least in our arms. So science can have a massive, can be extremely important. I think in a time of pandemic, it's a highly believable statement. And you'd think that considering how important it is, firms will just do it, right? They will do science themselves. But in fact, they don't. This graph taken from a recent study by a bunch of people at Duke University shows a consistent decrease in investment in science as measured by scientific publication by large firms across industries, right? This is a general phenomenon that even though we believe science is super important, both for the development of new technologies that is going to save people's lives, but also from an economic standpoint, you'd think that large firms will actually invest in it, and we see the exact opposite happen. We see less and less investment by large firms into science. Again, a testament that this is very, very hard stuff to do. Now you might think, okay, maybe they invest less in science because science is not useful for them, or maybe they do less innovation, but that's not true. You see, they actually do more and more innovation, and they exploit science more and more. They just don't want to do it themselves, right? It's so hard, even though it's so important, they use it, they just want someone else to do the hard work of de-risking it, right? If you think that there is something, there are a lot of gems inside academic labs, on the shelf of academic labs, but it's so hard to commercialize it that large firms will just shy away from it and not get involved in it, then you might think that possibly we're leaving money on the table. There are places in academia, ideas in academia that are not getting the attention that they deserve. That's the center of my own research. So of course, in studying this question of underutilized pieces of science in academia, we face a general, very, very simple and fundamental empirical challenge. When you see an idea that makes it out of the lab and gets commercialized, you know it was a good idea, right? But when you see an idea that does not make it out of the lab, how do you know if it's a bad idea or if you're leaving money on the table? To address this empirical challenge in my research, I use simultaneous discoveries to conduct what amounts to twin studies of ideas. Let me give you an example. In the spring of 2006, two teams of scientists simultaneously and independently discovered that interleukin-7 could be used to discriminate between regulatory and activated T cells. This discovery has important implications for the development of therapeutics for immune diseases. Yet, one of these teams was led by a woman, another one led by a man. When two teams of scientists make the same discovery around the same time, sending their paper for publications, both papers can actually get published, forming what I call paper twins. Just like twins, I mean real twins, people twins, have been used for decades to disentangle the impact of the gene from the impact on the environment around these genes. I use this idea twins to disentangle the impact of the knowledge itself, its commercial potential that was unobserved, from the impact of whichever variable I'm interested in, for instance, in this case, gender, right? So in a sense, what I'm doing in my research, in much of my research, is twin studies of ideas to identify instances in which an idea could have been developed to produce great new technologies, but was not. Right? And for instance, since I'm talking about that specific project on gender, it is true that all the challenges that women specifically face when it comes to STEMs and the commercialization of science means that on average, the idea that they make that might be just as good as those as men get a lot less exploited by firms. Now, considering this, I think it's especially important and amazing that we could get three amazing women with us today who are heroes trying to do what large firms don't dare doing, namely commercializing science and getting involved in deep tech. So it's really a great honor to have here to Sophie Cahen, the founder of and CEO of Ganymed Robotics. She's a graduate from Centrale Supélec in France and an alumna from INSEAD in 2016 and was named recently a Woman Entrepreneur of the Year. So thank you, Sophie, so much for being with us today. Why don't you start by telling us a little bit more about your journey?
Pleasure. Thank you very much for the interesting introduction and the quick bio. Hi, everyone. Thanks for connecting today. Yeah, so I'm co-founder and CEO of Ganymed Robotics. We're a surgical robotics company for hard tissue surgery, so that would be orthopedics. And I've had quite a varied start to my career. From engineering school, I moved on to academic research in the US on material science, before 1 year of private equity in a mid-cap fund in Europe, and then development banking in the Middle East, working for the French equivalent, the bilateral equivalent of the World Bank, which is the AFD in France, for those of you who know. Before coming back to Europe and co-design or redesign aircraft engine, turbine blades, and other complex items for the nuclear energy and aeronautics industry. So quite varied start. I think I got exposure to a lot of environments. Before coming to INSEAD, I'm a 16D graduate, as Michaël said. And then, let's say soon after INSEAD, I was lucky enough to meet the surgeons, computer-assisted surgery and robotics professional who became my business partners and early investors. And I think, I mean, it's been 3 years now. I'm happy if Michaël, you think it's relevant to tell a bit more about where we are now as a company. But it's true that it's sorry.
Yes, please.
Yeah, it's true that it's an interesting and challenging journey. So we started basically on the back of an envelope idea from the surgeons who were like, oh, we need you know, it's such a shame to do surgery the way today, the way we've been doing it for 40 years. They compared it to medieval woodworking, and if you've seen orthopedics, so if you had a surgery yourself, you know that it can be very approximative and quite invasive, so not very respectful of patient's anatomy. So they had this idea of doing something better. There was a robotician in the room. There was an expert in AI applied to medical imaging for surgical planning. And eventually, after much talking and with them putting on let's say the initial kinetic energy, we got started. And at the time, I think I was completely unconscious of the risk and what this would entail. Basically, I was embarking on a 10-year journey, and I'm at 3.5 years now. But there was no IP, no team, no real idea, no name of the company, no company actually. So everything had to be created. And today we are a team of 25 people. We filed for 7 patents with 5-6 more in the pipe now. One of them granted. And we've done 2 fundraising with one, a large one ongoing. We were recently named, we're EIC, so European Investment Commission laureates. So out of 65 laureates out of thousands of candidates in Europe for 12.5 million euro funding, part non-dilutive, part dilutive. So the idea here is really to entirely change the way hard tissue, so orthopedic surgery is done by developing an entirely new generation of robots that can see and perceive the surgical scene, make sense of it, detect and locate both anatomical structures and surgical tools. And so bringing computer vision and AI into the operating room. So far, AI has been used a lot in medicine, but mostly for pre-op or post-op or monitoring. But understanding the black box of the operating room is something that has not really been done before, especially in the context of a surgery. So we're working on that. And because it would be too easy, we're also designing entirely new hardware with breakthrough tech to actually guide the gesture of the surgeon without hindering it. And so now we are operating cadavers with the clinical precision. And we're in the process of industrializing both the software and the hardware part. And I've seen some people in the audience actually. Hi, Nicola from Cardiologs, who just who built AI companies for healthcare diagnostics and monitoring, and just recently exited. So congratulations. There's a path to victory for some of us out there. Yeah.
Thank you so much, Sophie. We have another entrepreneur with us today, Brittany Corsi, who got an idea during the Startup Studio in 2020 and decided to start a digital search engine focusing on energy goals and clean energy goals. So, Britt, thank you so much for being here with us. Can you tell us more about your journey?
Yeah, thank you. Thank you for having me, Michael. Thank you for also sharing those stories about your research. It inspired me while I was listening to it. So I hope other people get a little bit of inspiration from it too, not to give up on their journeys. So my journey is probably a little bit more of the non-traditional path. You kind of can see it now as you put together a puzzle, right? You see like the corner of the puzzle that starts to form based on the journey that you're on. And my journey started in startups, probably a little bit close to a decade now. And I had the opportunity to meet a great mentor and CEO that allowed me to learn and explore within the startup. So I was able to go into the various departments and operations, business, marketing, and finally technology, where I really was able to take those ideas that I had in my head and put them on paper and then make them a reality. And so from there, like Michael mentioned, I went into different startups and used those opportunities for growth and my development to be able to get to a point where I am now and use that information to guide my ability to get into technology, to build startups, and found FedTech, where Robyn will talk about. So I won't talk too much about the FedTech platform and organization itself, but but I was introduced to FedTech and was paired up with a technology from NASA, the NASA Power team. They focus on climate data. And through the research journey and seeing the data in those, in the climate information, we were able to say, okay, there's a lot of problems that obviously exist right now within the climate. But how do we make it easier for us to get to those solutions that we so desperately need right now in terms of our clean energy goals, green building, circular economies, and sustainability? So we use that deep tech from NASA and that satellite data and that climate data to build this digital ecosystem where we can model out different solutions and then take away all of the guesswork by using GIS and filling in those ecosystem members for people to be able to adopt those solutions. And that's a really interesting piece because it's, of course, ahead of its time. And like many of the stories that you told in the beginning, you get turned away really quickly when it's a new idea, and you know, we really haven't gotten to the problem part where we know that we need a solution yet. So it's definitely a journey, especially with new innovative solutions. It's something for anybody here that is on that path. You're going to have to go through it and you're going to get rejected and it's going to be difficult. But you just have to keep going if you really believe in it. And so now we're at the point where we're developing our extension of EarthXYZ, which is Earth ABC. We're working on our piloting. We're finishing out the development of that piece, working on development for equity options. And I think talking about some of the challenges that you know, we're at the beginning and then now is there's a gap, obviously, in your female youth being exposed to tech early on, right? So that's one of the challenges that we have to overcome. The next is getting the opportunity to have exposure to different startups and technology in the first place so that you can explore deep tech and you can explore to create innovative solutions. And then the capital piece, right? When you actually have a solution, when you have it in hand on table and you're presenting it in a silver platter, your early stage, you need money for development, you need resources, and that's a really big gap right now. So I think what we'll have to start doing is those bigger entities will have to start focusing on impact investing and really what's going to matter for us in the long term. So yeah, that's a little bit it.
Great, fascinating. Thank you.
Thank you.
A very interesting journey. Sophie, can you come back and tell us a little bit more, perhaps, about some of the main challenges that you face in your development?
Yeah, absolutely. Just maybe quickly a comment on the large companies. I think it's interesting. We talk, of course, to large players in our field who are like multi-billion companies, and they talk a lot about non-P&L R&D. Most of them are listed. They have like quarterly earnings call and all this stuff, and so they cannot spend too much on R&D. It's not. It used to be their DNA. It's not anymore. So what they do is look at what's happening, and they have huge M&A budgets. But because it doesn't. It's not considered as a cost and expense. It doesn't change the price earning ratio. It doesn't change lots of things. So they effectively outsource research, like fundamental research or development of risky technologies, to startups, which they eventually acquire. And I'm not sure if it's a winning move, but it's clearly what most of them are doing. And which is why you see so much science and technology development happening outside of the largest companies, because eventually, and that's what you see a lot in medical technology, especially, which is extremely hard. I think the difficulty in hard tech, deep tech, is, you know, when you look at what makes a startup successful, we usually have long development timelines, and so you can't really iterate. So you have to make wild, as informed and educated guesses as possible, but they're always going to be wild because you can't test your product before a very long time. So you can get you can get users in the room as much as you can. I mean, we do lots of that, but basically as long as it doesn't, the product hasn't met its market, and it doesn't meet its market for a relatively long development time. And this, of course, links it to the capital, the equity challenge. I mean, how do you raise funds when your first turnover might or might not be in 3, 4, 5, 6, 10 years time? And yet, like we have friends developing heart valves, life-saving drugs, etc. And this, and I think we are on a course to change the way surgery is performed for heart tissues in the human body, and these take a lot of time. However, I mean, this is a challenge. I think there has rarely been better time to invest in, to work and invest in deep tech. Especially, I'm based in France, which has a very, very supportive, let's say, very supportive network and financing ecosystem for the very early stage. It becomes trickier at the stage where we are, when we're still a few years away from the market, and we have 2025 still growing team with lots of capital requirements. We are not helped in deep tech, especially in medtech, by changing regulations, because they tend to affect our markets. They tend to affect lots of things for us. They affect our development very strongly. And the EU has not done a great job on that when it comes to medical device requirement and regulation. Most of us, and I know lots of startups, I'm very involved in the fascinating European Paris French ecosystem. We all have difficulties hiring, and I'm thinking of you MBA students in the audience. There probably are some of you here. The companies that we start, that we lead, that the solutions we're trying to build, they take a lot of talent. But we are less easy to find than the obvious names. We might take more time. We might have money one day and less money the next day, and it makes it risky choices. But I think over the long term, building a winning category leader is a sound career move, and probably very exciting, because they are very, I've never seen an industry or a more challenging job. Of course, being CEO does change, but it's also, you have to think about IP. We're a very IP heavy industry, commercialization, product features. How do you balance between the need to go fast and the desire to have as complete and sexiest product as possible? Like there's so many factors that make the journey a super ambiguous one, and so I think starting a company in deep tech is even more challenging than your standard SaaS company, because you don't even know what the metrics are. Like, are you going fast? Are you going slow? Are you on track? No one has developed what you're developing, so you can't know. If you're doing a software as a service, enterprise software, of course your tech is unique, and you're doing everything better than everyone else. But at the end of the day, like, there's KPIs, and investment funds are going to tell you what your KPIs ought to be if you don't know it yourself. For us, we don't know, and they don't know either. And so you need a very high level of conviction that you're doing your very best, that you have the very best possible team, and that you're solving a real issue. This, of course, we have surgeons who personally invested their personal money into the company. So, and we have more who are willing to. So this is a strong validation that we are actually solving a pain point. But surprisingly, it's not always convincing enough to investors. So there's a host of challenges here, from going from bench to bedside, or lab to operating room, and it's definitely a long journey. What's more, and I'll stop here because there's more to say by other panelists, is that every startup, every new endeavor is going to be a bet on a vision of the future. But this vision is more or less short or long term. And the longer term it is, the less traction and adhesion to your vision you're going to have around you. And so when you're in deep tech, you make it's a long-term game, which might lead to an early exit or an early valuation of the company, but it's still a long-term game for it to realize itself. And so typically we have friends who are starting like quantum quantum computing company, quantum crypto companies. Well, I mean, it's probably the future, but it might be the 20 to 30 year future. So you need to find people who see it the same way you do. And in surgery, the idea of saying, I mean, robotics is going to not to take over, but we will have like tech-powered, human-led surgery. There's going to be some collaboration between the two. Just like in aeronautics, there's going to be a black box inside every operating room that traces what's happening, and that feeds back to the surgeon what he or she should be doing differently, etc. That guides the gesture. We have this vision that a lot of people in the industry have, but it's not yet mainstream. And so it takes a lot of conviction to bring people on this side of the equation. And a lot of rejection, I would agree. Like, you have to be bulletproof, because you'll encounter, and it's true for Airbnb and others, like, because they had a strong vision of what the future was going to be, and so do we here at this table. But like, you meet like hundreds of people a day, probably especially if you're a woman, who first think they would do your job much better than you, which might or might not be true, and second, who think you're wasting your time, which hopefully is not true, but might or might not be true. And so, like, it takes a little bit of of strength.
Good wall.
Yeah, exactly.
Amazing. Thank you so much for sharing this. We hear stories about challenging access to talents. This is definitely a recurring thing. Challenging access to good science, to good ideas, and challenge to access to capital. I want to, Britt, do you have anything to add on this? I know you already mentioned some of those challenges earlier.
Yeah, I think, Sophie, you covered a lot of the bases, and I briefly touched on it before, but I think in the States, our biggest problem as a society is filling in those gaps between getting to the technology and having capital to get those people off of the ground in the first place. Otherwise, the innovation will just remain stagnant, and really only within university. So yeah, it'll be interesting to hear from Robyn, because I think they solve a huge gap.
Perfect transition. Couldn't be smoother. All right. Well, so we are very lucky again to have a third amazing panelist with us today. Robyn is actually at FedTech, which is an institutionalized way of dealing with some of those challenges, right? So we've been discussing all the pains, all the challenges that might lead to great ideas staying inside university labs, and all the missed opportunities and money left on the table. So some entrepreneurs are trying to do it themselves, but thank God there are people like Robyn out there who are there to help them and create an institution like FedTech is, to help entrepreneurs in that journey and increase their chance of success. So thank you so much, Robyn, for being with us. And can you tell us a bit more about FedTech, about yourself as well and FedTech?
Sure. Thanks, everybody. Love hearing the stories from Sophie and Britt. So a little bit about my background. So I've been in the space of deep tech and innovation for almost a decade now, starting my career as an attorney, but then kind of pivoting into this world in academia first. So having an experience working with New York University's Abu Dhabi campus, building from the ground up what didn't exist. There was no culture of innovation. There was no ecosystem. At that time, there wasn't a focus on entrepreneurship. So in that experience, really identifying, if you look at kind of a continuum of some of these issues that we've discussed, from the very inception of research being began inside of a lab, inside of a university, and then all the way, the very long, arduous process to actually commercialize that. That's where I really fell in love and spent a lot of time within academia before moving to FedTech. So what FedTech does, we're a US-based company, even though we do have a bit of an international reach, but what we do is we basically enable and we identify these gaps from misalignment of incentives, goals, and metrics that we've kind of all discussed within the lab, and we create access. We create access and the ability to commercialize technologies, and we do that in a programmatic way. So by that, I mean we run a host of different programs primarily with our stakeholders being government agencies. So you heard from Britt, she has developed a NASA technology. That's the National Aeronautics and Space Administration within the US. And we also work with the Department of Energy, Department of Defense, and a host of others, as well as universities. So the issue that we're trying to solve at FedTech is that you have an incredible amount of R&D money being spent for pure research. But what is misaligned at the beginning is that those researchers, they're pure researchers, they're career researchers, and they don't have the same goal or mindset of thinking of the research in a commercialized sense. They don't have that end goal of seeing it become a product or service. They are trying to solve an immediate need for that agency or service, and that could take many, many years. But what we identify through our program, and Britt was an entrepreneur in our startup studio process, is that we try to go and find on the shelf all of these technologies that just lay there. Really, if you really wanted to, you could find all of these patents that have been filed. It's publicly available information, and same as in Europe, but people don't know how to access it. So that's the same theme that we've been talking about today. They don't know how to do the diligence on it and identify those gems that are sitting on the shelf. So what our firm does is we have a host of technical experts that are PhDs in various fields. They help us identify technologies that could be ripe for commercialization. And then again, going to the point of access, we're not asking those federal researchers to quit their day jobs and go start a company. We ask for them to be part of the process and be advisors to a team of entrepreneurs that we will source and find. So at this point, we're allowing access where we're not taking equity in any companies that are formed. The government agencies that we work with, universities, are supporting us. So it's truly democratized access to any entrepreneur. So this goes to the point in equity. When you're talking about access to women, underrepresented minorities, other groups, that we have the luxury of completely removing those barriers so we can go out and find the best talent possible to form teams around these technologies. So that's the crux of what we do, is identify the technologies, find an amazing founding team, and then we create the framework and a program to get them to the point of validating whether that technology does have a commercial roadway. And then if it is, we help launch the business. So along the way, a big thing of what we do is de-risking it. This is a hugely risky endeavor, right? Trying to take a piece of raw technology. Again, these aren't products that we're working with. It's raw technology in a lab that we see potential in. And through our process, we try to de-risk it. And the other thing that we're really excited about is at the end of the spectrum, we have corporate partners. To Sophie's point, that is a trend. They're looking to almost outsource the riskiest part is the R&D. They can't afford that risk internally because of their own goals and accountability to their shareholders. So that is a trend that we've been seeing that we're able to take advantage of, is serving as that de-risking element to deliver companies and solutions for corporates that could be potential acquisition targets or partnerships. So very proud of the work that we've done. We've created about 70 companies through this. We do it at a pretty tremendous scale compared to other startup studios. And Britt's just one example of an entrepreneur that's done that successfully over time. But it's fraught with challenges. That's the whole theme here, right? I think funding is one of those things, and the time scale to do it. So funding is still an issue and something we help in our program leverage public available funding. So in the US, we have a program called the Small Business Innovation and Research Grants, or SBIR, which is one pathway to access public funding, but it's not nearly enough. So we do our best to try to harness other areas before private capital is even interested, because it's still, again, going to the beginning, that 0 to 1 phase is fraught with risk. So we do our best to accelerate through that valley of death, and then identify pathways for funding and growth through partnerships, private investing, and public funding as well. So I'll stop there. That was a lot, kind of jam-packed, but hopefully that made sense a little bit about our model.
Great, thank you so much, Robyn. I want to remind everybody that there is an option to ask any questions you might have. We have a great questions here from Mike Solchi about how you come up with valuation with your investors, giving breakthrough, if any, will occur in 5 to 10 years in the future. I don't know who might have a good answer here. Sophie, you want to go give it a shot?
I've been on both sides of these discussions, because when I was a P investor, now I'm for a very short time, and now I'm an entrepreneur. I mean, there's, you learn discounted cash flow in business school. You can throw that right directly to the trash. The way things are done is through comparables. I mean, I don't know if it's the same for Brit, but usually you look at companies in the same field that have either been listed or been sold, or what their market cap is, or whatever. And you look at where they were in terms of development stage. For us, it's pre FDA approval, post FDA approval, commercialization, what level, and the comparables way is the most used way to value private companies, and it remains the case in deep tech. Sometimes for people with zero comparables, but I don't think that would exist. I mean, you can look at, of course, the total addressable market, what you can do, and so based on an estimation of future revenues. But this has to be so much discounted with the level of risk that it's not very often used. And basically, in the end, it's supply demand. Like, how many people are willing to invest in your company? What share do they want? What amount of money do you want? What share do they want? And then you talk and talk and talk. And finally, if there's enough motivation on both sides, you end up to a deal, and that values the company. Britt, is that your experience as well?
Very pragmatic. Yeah, Britt?
Yeah, so yeah, you're a little bit ahead of me in terms of your journey still. So mine, Michael, to answer on your side, if it's early stage, a lot of the stuff is made up. When you're at an early stage, you do your market evaluation and the opportunity, but until you get investments and until you're really in a revenue cycle, you're really throwing stuff in the air, or spaghetti at the wall, I would say, and waiting until something grows. But Sophie, you're spot on for when you're at that level. Yeah.
Great, thank you. If there is no more answer from the audience, I'd like to ask Robyn, what are some of the main mistakes and failures that you see people make in commercializing science like that?
They don't find a problem. So they're just completely isolated in the lab, and they don't do kind of the fundamentals of what you tell any entrepreneur or startup is get out and go talk to potential stakeholders and customers. So a technology could be developed for quite a long time without understanding what the potential could be, because they've never gone out and done their customer discovery to really understand there is a problem, the size of that problem, and where exactly it could translate into an opportunity. And again, this goes to the misalignment of focusing on our inventors and researchers to be those individuals that do discover that. So that's kind of why we come in early to help navigate and figure that out. So that's the biggest thing that I see, one of the challenges that we're trying to address. And then from the entrepreneurs, another common thing, it's the simplest things as well. The difficulty of misalignment of expectation when it comes to the time scale is completely different than if you're looking to stand up a SaaS company with limited capital requirements to begin, or access to facilities to perform R&D, or a regulatory pathway that is complex. So oftentimes we see a misalignment of commitment and expectations from maybe first-time founders, in this case, really understanding the path that they're about to embark on. So we really do our best to help people understand that the time scale here isn't days and weeks, it's months and years, which is very different than looking to start ventures in different spaces. So those are two kind of big ones off the top of my head that we see.
Great. There's another question. Sophie, you want to add to this?
Yeah, just one small point, maybe on the topic of funding. is that, you know, we all read the papers, I'm assuming, and, you know, what you keep reading, there hasn't been as much money in the system ever. You know, this capital is cheap, it's a commodity, blah, 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 blah. Well, it's certainly true on one side of the table, a bit less on the other. And I think what's happening here is it's true. I mean, there is a lot of money on the market. There is a lot of dry powder a lot of capital to be deployed. But what we see happening, at least in Europe, and I think it's probably the same in the US, usually like they're ahead of Europe for capital transit by a few years, if not decades, is that there's more and more money going to the same companies. So now the rounds are 200, 300, 400 million euros or dollars, when there used to be a tenth of that. And so, you know, this is all the more money that doesn't go to smaller and perhaps riskier companies. And so it's true. Well, I mean, while it's true that there's more money in the system, the competition for funding has become fiercer as well. It's a double effect where, in fact, at least deep tech companies do not win.
Fascinating. We have another question for Robyn by Dennis, asking, Robyn, does the fact that research is sitting unused in the shelf at universities without an idea of how to commercialize mean that you are able to bargain hunt? I understand the de-risking value. I guess I'm wondering how much the return the universities and researchers ask for as a share of the commercialization.
Sure. So I'll try not to geek out, but it's a really complicated answer. But basically, each university and each lab that we deal with, we're not dealing directly and negotiating with the researcher. We're negotiating with the institution. So the technology transfer professionals. So there are many mechanisms and agreements, legal contracts and agreements that can form. Some can be co-development agreements, some can be licenses. And that's where you see an exchange of potential. In the university's case, you could have equity in a company. We don't see that in our labs. They're not able to take equity in the companies, but they do get a share of royalties that come out of it, and it's a negotiation like anything else. So what the companies have to go to the table is demonstrating they have a solid plan, communicating that they are the business to license that technology and create value. So the earlier, right, the entrepreneurs do have leverage because they're coming in earlier, where larger companies aren't looking at these technologies because they're too early stage and it's unknown, the development process. So in that sense, coming in early, creating that access and pathway, we create a direct access to those technology transfer professionals. They're part of our process. It gives them a leg up. But you have the Fairness of Opportunity Act. So it's not like we can guarantee it. We just give them access, and then it's a negotiation per lab on what type of agreement would be set upon.
Right. So there is some international variation. In the US, most of the ownership goes to the institution. It's not true all over the world. I don't think it's true in Canada. I don't think it's true in most of Europe. Many European countries actually give ownership of the discovery to the scientists themselves. The benefit of giving ownership to the university, this is what the Bayh-Dole Act achieved in the early 80s, was to give an incentive to create those technology licensing offices and actually provide some of this infrastructure that is so helpful and so important so that the technology gets out. And many researchers have credited the big tech boom, biotech boom in the early 80s to this reform, for instance. We have a question by Jaslyn about talent. What are the talent gaps for early stage startups and new technologies like yours? He wants to answer, yeah, or Britt? Go for it.
Lots of them. So typically, I mean, our case right now at the moment is we've been struggling for almost 7 to 8 months to find an experienced senior medical device project manager / program manager. So it took us forever. So, the timescales are longer in Europe than in the US because your notice period is 3 months as a minimum in Europe. And so the time you find a candidate and then it takes forever for them to join, but still. We have been looking for a computer vision research scientist to complement our computer vision team for the past 4 months, and we've interviewed dozens of candidates and it doesn't work. And and we have like a great talent pool in France, but it takes a while. And then we need to seniorize the team a lot on a lot of verticals, from clinical, regulatory. There's also business development, sales, even strategy. I would really want some help when we get more funding to pay for all these people. And these are talents that are not easy to find. Very early on, I'm an INSEAD grad, as I mentioned, and my COO, so my right arm, is also an INSEAD grad with a lot of medtech and startup experience. And you need that just to figure out what are the least dumb move. I think it's the best you can do, is the least stupid next move you can make to move towards the direction of your goal. So it's there's a lot of specific expertise to the industry, but also some really broad-based overall, I'd say, cognitive and relation building ability to attract the right candidates, strike the right partnerships, convince investors, and come up with the right vision, perceive weak market signals, which is always important at the beginning of a deep tech, because the market's not going to tell you exactly what they want, because it might not exist, or you don't have any product to show. And so there's some very fine perceptive ability that you look for in people as well. Not sure it answers the question, so I'll let Britt follow up on it.
Yeah, Sophie, that's good. You might, I know it's probably more expensive, but you might want to consider executive search so they can find those people for you. But yeah, I'd say
it takes forever with executive search companies, and sometimes it works and sometimes it doesn't, and then you have to let people go, and it's a nightmare. Anyway, stuff.
I'd say technology is probably one of the talent gaps that a lot of, whether early stage or smaller companies, I think it's going to increase more, primarily because you have your big tech companies where college graduates come out and they can bust out 6 figures, right? They're paying for that. So joining an early stage for sweat equity is not something people want to do anymore. And then when you throw things like COVID into the mix, that upsets the entire economic balance. Income is everybody's first priority. So I think with early stages, it's how do you find the people to even create together in the first place? And then how do you battle against big tech to grow and scale?
I would add to that maybe something that I've noticed with candidates, because I speak to a lot of junior and sometimes more senior candidates, and they have, at least for the French ecosystem, a very skewed perception of what constitutes a risk. Like in France, if you're laid off because your startup doesn't have any more money, the government pays for your salary for 2 years. So it's not clear for me exactly what they mean by, oh, it's such a risk to join a startup. I'm like, what kind of risk are you talking about exactly? The risk of having a fascinating job and finally using the entire spectrum of your abilities versus being underutilized somewhere else. Like and getting equity versus not getting equity. Like, please explain something, I'm not fully getting it. So there's I think people, and it applies to people who are considering different career paths, is you can't make a rational decision if you have a perception of risk that is like completely biased with all the cognitive bias that we know we have as humans. It's the loss aversion, all this stuff. At least on a French from a French perspective, I see a lot of candidates who are just talking nonsense from a risk evaluation perspective, and a lot of them do not join us for that reason. And of course, it breaks my heart, because sometimes they're very good candidates, even though they apparently are not factoring in cognitive bias as much as they should. But so the appeal of small startups is not where it should be, especially when you look at how gratifying the job itself can be. My 2 cents, but of course I'm also biased here.
Great. So it's 5:59. I'm not sure that I'm allowed to ask another question. If you have any last thoughts for an audience interested in deep tech, any thoughts, do it. One thing to keep in mind. Maybe Robyn or Britt or well, Sophie, go ahead. You're gonna.
No, I mean, I was looking at the questions on the questionnaire, and you know, Mohammed, the one on the MDR is too specific, but we can take it offline. Is the risk averse a specific French attitude? Lol. I mean, these are questions to take offline because they're a bit audience specific. But yes, I mean, the conclusion here is that deep tech is for me, I mean, it's probably something I'll keep doing from company to the next, because it's about solving really big issues with a level of ambition that matches the level of the challenges that are in the world ahead. It's, if you've ever had, and I think it's everybody's case around this table, the feeling of being entirely underutilized in your previous jobs, that that you could do so much more, and then you're here shuffling paper around, whatever name that job is called, consulting, banking, whatever, then you might think there's more to be done. And these are companies and projects that are harder to find. They take more of your bandwidth, but they also give you more in terms of the learning curve and the impact you have on the world. So this would be my parting thoughts from a deep tech founder perspective.
Thank you. Robyn?
I can just chime in. I would say if you're going to endeavor this, it could be a lonely journey. So find power in your network and community and local community, and kind of lean on those people, other people that are out ahead of you. Find mentors in the community if you're thinking about starting it on your own. I think that's a really, really important thing to have, is make sure that you're building your own network in this ecosystem and community, because it is a different pathway. So you want people that have been there, done that. You want to really have those people in your corner.
Great, thank you. Britt?
Absolutely, Robyn and Sophie. Just don't give up, right? If you feel it inside of you that this is where you're supposed to be, keep going. And if you're called to do something, you're called to do it, and you just have to listen to it and follow the journey. And it's going to be a rough one, but you got to go.
If Kathleen Carrico hadn't persevered, many of us would not have the same kind of level of protection from COVID. So by all means, keep going. Thank you all so much for coming. Thank you, panelists, for an amazing discussion. And I guess everyone, don't forget there is the upcoming seminar next week about taking blockchain to the luxury watch market. Thank you so much again for everything.
Thank you, everyone. Bye.